Hello everyone. In this lecture we will see the fundamental topic in artificial intelligence, that is supervised machine learning. So this is where the machines learn from labeled data to make predictions or decisions. So by the end of this we will understand what supervised learning is, how it works and where it's applied in the real world. So before we talk about supervised learning, let's see what machine learning is. So machine learning is a subset of AI where systems learn from data without being explicitly programmed. So here we can think of it like a human and think of it like a machine. So for example, think of it like teaching a child, that is, instead of giving rigid instructions, we show examples and let them generalize the patterns. So for instance, if we show a child many pictures of cats and dogs, they eventually learn to distinguish between them, right? So here machines do the same but with algorithms. So here when do we use this machine learning? Machine learning is not the answer to every problem. We will use it when the problem is too complex for traditional programming, that is recognizing handwritten digits, and the data is vast and patterns are hidden, that is predicting stock prices, and when the environment changes and the system must adapt, that is, for example, spam detection in emails. So for example, writing rules to detect spam emails manually is impractical because spammers constantly change the tactics. So MI model learns from thousands of emails and adapts automatically, right? So next is data types in machine learning. So it has two primary forms, that is structured data and unstructured data. Structured data is the one organized in tables, that is Excel sheets, SQL databases, like that. So each column is a feature and rows are instances. And unstructured data, no predefined format for that. For example, images, audio, text, all are unstructured data. So features are the measurable inputs like the patient's age, blood pressure and symptoms in a medical diagnosis model. The better the features, the better the model's predictions. So these are features, inputs of the machine learning for where it shows the example of unstructured data. And next, this machine learning is broadly categorized into four types. One is supervised learning and unsupervised learning, semi-supervised learning and reinforcement learning. So four types of machine learning. So we'll see one by one. So first we'll see the gist of what is what. So supervised learning learns from the labeled data, that is input output pairs will be there. So for example, predicting the house prices based on past sales. And so unsupervised learning is finding the patterns in unlabeled data. For example, grouping customers by purchasing behavior. And then semi-supervised learning, it uses a mix of labeled and unlabeled data. And reinforcement learning is learns by trial and error using rewards. So training a robot to walk. So that is an example for reinforcement learning. So in this lecture we will be focusing on supervised learning, which is most common and widely applied type. Okay. So here in supervised learning, the algorithm learns from a training data set where each example has an input and correct output. So it's like a teacher supervising a student's work. The goal is to learn a mapping from inputs to outputs so that for new unseen data the model can predict accurately. So for example, in a data set of emails labeled spam or not spam, the models learns to classify new emails automatically. And then we have classification in supervised learning. So one major task in supervised learning is the classification, where output is a category. For example, we have a binary classification. So this is the one where we have yes or no outcomes. So here, for example, tumor is benign or malignant. This is a type of binary classification. And then we have a multi-class classification, so where we have more than 2 categories. For example, recognizing the digits. So algorithms like decision trees, support vector machine, and neural networks are commonly used. For example, banks use classification to approve or reject the loan applications based on the credit history. And then next we have regression in supervised learning. So this second major task, where the output is a continuous values. So predicting house price based on size, location, etc. So on forecasting the stock prices. So unlike classification, regression deals with numerical outcomes. So linear regression is the simplest algorithm here, which is to be fitting a line to the data points to predict future values. Okay. And then see the applications of supervised learning. So supervised learning is everywhere. In healthcare, diagnosing diseases from medical scans, and in case of finance, credit scoring for loans, and in case of retail, recommending the products. For example, Amazon's customers who bought this also bought, like that we will be seeing a dialog box, right? So that is a retail. And autonomous vehicles, recognizing the traffic signs. So these applications will show how supervised learning transforms industries by automating the decision making. Okay. Then pros and cons of this. While powerful, this supervised learning has again some of the pros and some cons are there. So where we have seen, if we see advantage, high accuracy with enough labeled data, interpretability, for example decision trees, and then it is a wide applicability. Okay. And the limitations, so it requires large labeled data sets. For example, labeled data sets are, if it is large, means it is expensive or time consuming to create, and then struggles with unseen data patterns and can overfit if it is not regularized. So that is the limitations for the supervised learning. So for example, a model trained only on daytime images might fail at night. Okay, so this is why data quality and diversity matter here. So supervised learning is about learning from labeled examples to predict future outcomes. It excels in classification and regression tasks, we have seen, driving innovations across fields. Okay, thank you.